We're going to continue our lesson on partial fraction decomposition. Now, previously we looked at denominators that were quadratic. So let's look at a few that are cubic, and we're still going to continue the same process. So we have a rational expression that has a cubic denominator, but this needs to still be factored. So as I look at x cubed minus 3x squared minus 28x, we can factor out a greatest common factor of x. So if we did factor out an x, we would be left with x times x squared minus 3x minus 28. But that could continue to factor. So that would factor into x times x minus 7 times x plus 4. What we can now say is that this rational expression, 5x squared minus 34x minus 84, can be rewritten with a denominator of x times x minus 7 times x plus 4. Now, if we continue what we were previously doing, we're breaking this down into partial fractions with distinct linear denominators. So we're not going to go into some of the more complicated partial fraction decomposition that you might see when you get to a calculus class, but all of these denominators are linear factors. So we would have one fraction that could have a denominator of x, another fraction that has a denominator of x minus 7, and a third fraction with a denominator of x plus 4. We continue doing the process of multiplying by that least common denominator, and that's going to eliminate our fractions. So if I multiply by that common denominator on both sides, we should eliminate our fractions. In that first fraction, we just have 5x squared minus 34x minus 84. And then when we multiply on the right side, we're multiplying a over x times our common denominator, x times x minus 7 times x plus 4. The common factor of x's would divide out and leave me with a times x minus 7 times x plus 4. Then we multiply the second fraction. We're going to get b times x plus 4 plus c times x minus 7. There are three components to this, so we're going to need to do the critical value method 3 times or set up the system of equations. So to do the critical value method, we're still looking at what critical values of x would make the denominator equal to 0. And so one of them is when x is 0. So I'm going to let x equal 0 for right now. That would be 5 times 0 squared minus 34 times 0 minus 84 is equal to a times 0 minus 7 times 0 plus 4 plus b times 0 plus 4 and c times 0 minus 7. Now on the left side, we're going to have negative 84 equals, and on the right side, you have b times 0, which is 0, and 0 times anything, 0 times 4 here, is still going to be 0. So the b's will disappear, but so will the c's. C times 0 is 0, so we're adding 0 from that b times 0, we're adding 0 from the c times 0. All that we're really left with is the a times 0 minus 7 times 0 plus 4, which would leave me with negative 28a. We divide both sides by negative 28. So negative 84 divided by negative 28 is positive 3. A, in that case, is equal to 3. Then we want to do the same process again with a different critical value. So as I look at the second fraction, b over x minus 7, that denominator would equal 0 when x is 7. So that's going to be my second critical value I'm choosing. So 5 times 7 squared minus 34 times 7 minus 84 is equal to a times 7 minus 7 times 7 plus 4 plus b times 7 plus 4 plus c times 7 minus 7. Now, as we work through these, we're going to see that 7 minus 7 is 0, and 7 minus 7 is 0 here. So we get a times 0 and c times 0. That's going to eliminate the a's and the c's and leave me with just b stuff on the right side. So let's look at the left side first, though. 5 times 7 squared minus 34 times 7 minus 84 gives me a left side equal to negative 77. A times 0 disappears because that's just 0, so 0 plus. Then we have b times 7 plus 4. So that's 7 times 11, which is 77, 77b. If I divide by 77, we'll get b is negative 1. We do this a third time to figure out what c is equal to. So we're going to let x equal negative 4. That would say 5 times negative 4 squared minus 34 times negative 4 minus 84 is equal to a times negative 4 minus 7 times negative 4 plus 4 plus b times negative 4 times negative 4 plus 4 plus c times negative 4 times negative 4 minus 7. We work out the left side. 5 times negative 4 squared minus 34 times negative 4 minus 84 should give me 132. All right, then we look at the right side, and you should notice that negative 4 plus 4 is 0, so we have a times negative 11 times 0, which is still 0a. We get b times negative 4 times 0, which is still 0b. But then on the last part, negative 4 times negative 11 would be positive 44. So 44c. And we divide by 44. So 132 divided by 44 is 3. These take up a lot of space, but we did find a, b, and c. So the partial fraction decomposition for this would say 3 over x plus negative 1 over x minus 7 plus 3 over x plus 4. We're plugging in what we found for a, b, and c. So that is our final answer, our solution to the decomposition. But you could do this with a system of equations. So if I take the original equation that we had before we started doing the critical value method, we would multiply out and distribute what we have. So I'm going to do that right here, but I'm not going to finish this all the way. I'm just going to kind of set some things up for you. This would be a times, and you have x minus 7 times x plus 4, which is x squared minus 3x minus 28. Actually, let me move this to a bigger sheet of paper. So 5x squared minus 34x minus 84 is equal to a times x squared minus 3x minus 28 plus b times x squared plus 4x plus c times x squared minus 7x. If we've distributed just the parts that are being multiplied with the a, b, and c, and then we can distribute out the a, b, c's. That would give me ax squared minus 3ax minus 28a plus bx squared plus 4bx and plus cx squared minus 7cx. Again, what we're doing is combining all of the quadratic parts, the linear parts, and the constant parts. So if we reorganize this, 5x squared minus 34x minus 84 is equal to ax squared plus bx squared and plus cx squared minus 3ax plus 4bx minus 7cx. And then our constant term was minus 28a. If we look at each part, our quadratic part was 5x squared. It would come from each of these x squared terms. We have a negative 34x, and it would come from the minus 3ax plus 4bx minus 7cx. And we have our last part. That is just the negative 84. And it's coming from this minus 28a. So you would set up your system of equations using those components. The 5x squared is coming from the a plus b plus c. The negative 34 is coming from the negative 3a plus 4b minus 7c. And then lastly, the negative 84 is solely coming from this minus 28a. We have a system of equations that happens to be 3 variables, and you would solve that accordingly. This one's not terrible to solve because you already have one equation that you can solve for a. Once you have a, you can substitute back in and solve for b and c. So using whichever process you like the best, go ahead and pause the video and see if you can try number 6 on your own. If you're ready, you can go ahead and continue, press play, or when you're ready, press play, and we'll go over it together. All right. So for me, I would go ahead and factor that denominator. If I factor out an x, I have x times 3x squared plus 2x minus 1, which would continue to factor. All right, so it would factor into x times 3x minus 1 times x plus 1. And that gives me the setup for our partial, our partial fractions. So we have 32x squared plus 2x minus 2 over the denominator is x times 3x minus 1 times x plus 1. So we set up our partial fractions. One of those partial fractions would be a over x. Another would be b over 3x minus 1. And then c over x plus 1. If I multiply by that common denominator, it should eliminate the fractions. So x times 3x minus 1 times x plus 1. And we would distribute that to each fraction. That leaves me with 32x squared plus 2x minus 2 equals a times 3x minus 1 times x plus 1 plus b x times x plus 1 plus c x times 3x minus 1. I'm going to use the critical value method, so I'm going to let x equal 0 for the first one. If we do that, you should end up with negative 2 is equal to negative 1a. In that case, a is equal to positive 2 if you divide by negative 1. All right, then we're going to let x equal 1/3. This is coming from that denominator 3x minus 1. 3x minus 1 would equal 0 when x is 1/3. So for this one, I might need to do a little bit more math with the calculator, but 32 times 1/3 squared plus 2 times 1/3 minus 2 gives me a fraction on the left side of 20/9, 20/9. So 20/9 is equal to, and I would plug in 1/3 for each of the x's here on the right side as well, but that's going to say 3 times 1/3, which is 1. 1 minus 1 is 0. So we're going to get 0 for this factor of 3x minus 1. A times 0 times anything is still going to be 0. But we have here in the middle, b times 1/3 times 1/3 plus 1. So if you need to do that in your calculator, you can. But we get 4/9. So that would say 4/9 b. When you divide by 4/9, you should get 5. And the last one, we're going to let x equal -1. And we're plugging that in as well. So the left side is positive 28. If I plug in -1 into x plus 1, that'd be -1 plus 1, which is 0. 0 times anything is 0, so the a's are going to disappear, but so will the b's. We end up with c times -1 times 3 times -1 minus 1. That would be -4 times -1, which is positive 4, so 4c. In that case, c is 7. So we found out what a, b, and c were. We write our partial fractions. Our answer should say 2 over x plus 5 over 3x minus 1 plus 7 over x plus 1. All right, so those are the types of questions that we're going to run into. When you get to calculus, you'll look at a few more of these that are a little bit more complicated denominators, but we're sticking to when we have distinct linear denominators. All right, so if you need more practice, there are some more examples posted and an answer key that you can use to help practice those.